Okay, then I'm going to start. Okay, so we were doing examples. Okay, some more examples we will do on trigonometric identities, the formula that we just. Okay, so here let me copy the question first. Okay, you see here, prove that sine theta minus cos theta plus 1 upon sine theta plus cos theta minus 1 is equal to 1 upon sine theta minus tan theta using the identity. Okay, it's already mentioned that which identity you are going to use to solve this problem. Okay, so let's check the question and just try to do it. Okay, so I am taking LHS as it is a proof question. Sine theta minus cos theta plus 1 upon sine theta plus cos theta minus 1. Okay. Now I have to make this sine and cos instead of sine as cos if I want to make it into sec and tan. Okay, so you can see I already told you the identity that tan is equal to sine theta upon cos theta. Okay, so if we will divide in the numerator and denominator both the ones, if you are going to divide with cos, then let's see, dividing by cos theta. Okay, I'm dividing both the terms, all the terms by cos theta. So sine theta by cos theta will give you tan theta. Okay, minus cos theta upon cos theta will give you 1. Okay, and 1 upon cos theta will give you sec theta. Okay, everybody. Now, similarly in the denominator also, because if I'm multiplying dividing in the numerator, I have to do the same thing in the denominator also. So sin theta upon cos theta will give you tan theta plus cos theta upon cos theta will give you 1 minus 1 upon cos theta will give you sec theta. Okay, so we have got this term. Okay, now if you will rearrange it, so we'll get as tan theta plus sec theta minus 1. Okay, upon tan theta minus sec theta plus 1. Okay, now to further simplify it, what I'm doing, I am multiplying again numerator denominator both with tan theta minus sec theta. Okay, so that I can have the identity of tan square theta plus sec square theta. Okay, so if you will multiply with tan theta minus sec theta in the numerator, you see if this term, okay, this term will be multiplied first with this, and then this will be multiplied with this. Okay, so what will be our answer? Will get as tan theta plus sec. Okay, I'm writing the complete statement. Okay, don't get confused. Plus sec theta in one bracket, I will multiply tan theta minus sec theta. Okay, and the another one will be minus.
Good evening, ma'am.
Good evening, Shazan. Sec theta.
Ma'am.
Yes.
Nothing, ma'am. You carry on with the explanation.
Okay. So now in the denominator, if you see, so in the denominator also see tan minus theta. So I'm leaving in denominator. I'm not touching anything in the denominator. Okay. So it will be tan theta minus sec theta plus 1 upon tan theta minus sec theta. Okay. Now this whole is a plus b, a minus b. Okay. So now what I can do, I can just write it as a square minus b square. Okay. So in the numerator, I can write tan square theta minus sec square theta. Okay. Minus tan theta minus sec theta. Okay. Now, again, denominator will be.
Let's do the question.
This is your question. Prove that sine theta minus cos theta plus 1 upon sine theta plus cos theta minus 1 is equal to 1 upon sec theta minus tan theta. Using the identity.
I wasn't telling identity.
We did that using the identity sec square theta plus 1 plus tan square theta. Okay. Now, and from the starting, I'll show you. Okay. See, if you want to check.
In the previous class, I wasn't there. So can you recap?
Okay. Okay, let me finish this question, Shazan. Okay, and then I will recap it. I think you were there till this when I told the identities.
No,
okay?
I was till as you started identity, I left at that.
Okay, you were not there in the identities. Okay, so
no,
quickly review it, revise it. Okay.
First do the sum. Complete the sum first.
I'm just telling you the thing because in this trigonometric identities only three formulas were there. Okay, the main three formulas. I'm just telling you about the main three formulas because we are going to use that among them only. Okay, the first one is sine square theta. You will see here the first one is sine square theta plus cos square theta is equal to 1. Okay, this is the first identity. Okay, that the square of sine theta plus the square of cos theta will give you equal to 1. Okay, so whenever you can, whenever you're simplifying a question or trying to prove, you see sine square theta plus cos square theta, you can write it as equal to 1. Or in fact, sometimes you may need that you have to cancel some of the terms. Okay, so instead of 1, you can write it as sine square theta plus cos square theta also. Okay, so either way, both are correct. Okay, Similarly, the second identity is 1 plus tan square theta is equal to sec square theta. In fact, 1 will be equal to sec square theta minus tan square theta. So 1 can be written as sin square theta plus cos square theta also, and it can be written as sec square theta minus tan square theta and cosec square theta minus cot square theta. According to your question, according to the proof, according to what is given, what it is asking to prove, accordingly you can use the identities. Okay. So you have to remember these main three identities. Okay. That in fact.
Wait, I want to note it down.
Okay, the first identity, if you see the first identity, everybody, sin square theta plus cos square theta is equal to 1. So if you are going to multiply sin square theta, the whole first term, by sin square theta, so what you will get? Sin square theta upon sin square theta will give you 1. Cos square theta upon sin square theta will give you cot square theta is equal to 1 upon sin square theta will give you cosec square theta. So in meanwhile, if you don't remember the other two, then from first one only you can derive the other two also. Okay, sin square, if you're going to divide the first formula, first identity with sin square theta, so you are going to get the third identity. Okay, 1 plus cot square theta is equal to cosec square theta. And if you are going to divide the first identity from cos square theta, so you see sin square theta upon cos square theta will give you tan square theta plus cos square theta upon cos square theta will give you 1 is equal to 1 upon cos square theta will give you sec square theta. So 1 plus tan square theta is equal to sec square theta. Is it clear? Okay, and from these only we have derived other many more identities. Okay. Okay, so you can see sin theta can be written as sin theta also, and if you have to write sin theta in terms of cos theta, so how can you write? You can write from the first identity, if you see, so you can write as root 1 minus cos square theta. Okay, you can see tan theta divided by 1 minus tan square theta. So how can you write sin in terms of tan? If you see this the third identity where it is written cot square theta plus 1 is equal to cosec square theta. So cosec square theta can be written upon 1 upon sin square theta, and cot theta can be written as what? 1 upon cos square theta upon sin square theta. Okay, so you can change it in form of tan also, or you can simply write 1 upon tan square theta. Okay, so from there you can derive that sin theta in terms of tan can be written as tan upon root 1 plus tan square theta. Okay, so if you remember the above three identities and some more identities that I told you, some more that tan theta is equal to sin upon cos, cot theta is equal to cos upon tan, cos upon sin, and the inverse of sin theta is 1 upon cosec, cos is 1 upon sec, tan is 1 upon cot. Okay, so from them you can derive all these new identities. Okay, understood everybody? Okay, sometimes in question, instead of sin, you can represent the sign in terms of cot, in terms of tan. So how you can do it? From these formulas. Okay, now we were doing many sums we have done yesterday also. And then I was doing this, so let's complete this first. And then, okay, so here if you see, so I have changed the sign theta. Now you can see the question, sin theta minus cos theta plus 1. Now I want the sin and cos to be converted into tan. Okay, the two things that you can see, tan and sec in your question, you have to change it into tan and sec. And if I'm going to divide this whole term in the numerator and denominator, everybody, with sin theta, so I can change it into tan and sec. Sin theta upon sin theta will give me tan theta. Cos theta upon sin theta will give me, upon, I'm dividing with cos theta. No? Sin theta upon cos theta will give me tan theta minus cos theta upon sin theta will give you cos theta. Cos theta upon cos theta will give you 1. 1 upon cos theta will give you sec theta. Okay, you can see here. After dividing by cos theta, I got this term. Okay, now to more simplify what I'm doing, I am multiplying with tan theta minus sec theta in the numerator and denominator both. Okay, because if I'm multiplying, I have to do on both the means denominator and numerator both side. Okay, because if I'm multiplying both sides, then tan theta minus sec theta, tan theta by sec theta can give you only 1. Sec theta can give you only 1.
Can you
Yes,
start
Sophia?
from the beginning? I didn't understand.
Yes, Sophia?
Can you start
Same
from the
question?
beginning again?
Same question from side.
Yeah.
Let me visit and I will start again. Okay, just a minute. So, just synchronize. Demonstration is not synchronizing. Is it simple? Yeah. So LHS. Now the question is here. Okay. So you have to prove that sin theta. Okay. Sin square theta. Now you will see the question here. Okay. Sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon sec theta plus tan theta. So you have to prove that the LHS is equal to RHS by using the identity sec square theta is equal to 1 plus tan square theta. Okay. Now, if you see the question here, writing the question, that is sin LHS I'm writing. Okay, cos theta plus 1 upon sin theta plus cos theta plus minus 1. Okay. Now, In the RHS, if you see, it is sec theta and tan theta. And in fact, it is asked you also to use the identity of sec square theta plus tan square theta. So how can we change the given term in second tan? Okay. So for changing the given terms in second tan, what I'm going to do, I'm dividing the equation, dividing by cos theta. Okay. Both numerator and denominator, both you will be dividing. Okay. So if you will divide upon, I'll write complete so nobody get confused. Theta minus cos theta upon cos theta plus 1 upon cos theta. Okay. Sin theta upon cos theta plus cos theta upon cos theta minus 1 upon cos theta. Okay. Is it clear to everybody? Okay. Now, if you see in the numerator, okay, I'm just switching the pen so that it's clear. Okay. Sin theta upon cos theta will give you what? Tan theta. Okay. And then minus cos theta upon cos theta will give you 1 plus 1 upon cos theta will give you sec theta. Okay. Now in the numerator, in the denominator, if you see sin theta upon cos theta, again it will give you tan theta plus cos theta upon cos theta will give you 1 minus 1 upon cos theta will give you sec theta. Okay, I can see one line now. Okay, till now, anybody has have any doubt here? Okay, so this was the term that we have. Now, further, if you see, how can we simplify? Okay, so we have to get the term here 1 upon sec theta minus tan theta. Okay, now here we cannot get just write the 1 upon sec theta, but we have to do something more. But here, what you see, can you do anything else here? Okay, so what I'm going to do, I'm going to multiply with tan theta and sec theta, both the denominator also and the numerator also. Okay, by sec theta, wait, tan theta minus sec theta, I'm multiplying. Okay, oh, why this? Okay, multiplying by tan theta minus sec theta.
I
Okay,
will read the same question once again.
yeah, actually, Safia told me that
Oh,
he
okay,
needed
ma'am.
explanation. Okay, so I did it all the step. Which step I missed, that also I am writing it here. Okay, so that nobody faced the issue. Okay, now if you see here, so tan theta, I'm rearranging it. Okay, the tan theta term and sec theta, I'm writing it one place. Sec theta minus 1, okay, in one bracket, and I'm multiplying with tan theta minus sec theta. Okay, now in the denominator, if you see here, so it is tan theta minus sec theta plus 1, okay, tan theta minus sec theta. Okay, if you see why I have multiplied with tan theta minus sec theta in the numerator, if you see, if you multiply with tan theta plus sec theta into tan theta minus sec theta, so you can cancel the term. How? Let's see here. Yeah, again, tan theta plus sec theta multiplied by tan theta minus sec theta. Okay, and the another term is minus 1. So from 1, if I multiply, so I'll just simply copy the terms. Okay, and in the numerator, I'm leaving everything like that. Okay, tan theta minus sec theta plus 1 and tan theta minus sec theta. If you see here in the question, everybody, so you can see you have to prove 1 upon sec theta minus tan theta. Okay, and in the denominator, we have got 1 upon tan theta minus sec theta. Let's see what we can do. Okay, so if you see the first term here, okay, here, okay, this term. So it is of the form a plus b, a minus b. Am I right? Yes. So I'm going to change it. Okay. So it can be written as tan square theta minus sec square theta in one bracket minus tan theta minus sec theta. Okay, upon tan theta minus sec theta plus 1 upon tan theta minus sec theta. Okay. Now, tan theta minus sec theta can be written as 1 or not. I'll write the identity here. Okay. So, you have got the identity of 1 plus tan square theta is equal to sec square theta. Yes. You can see here in the question also. Where was the question? Sec square theta is equal to 1 plus tan square theta. Okay. So, from this identity only, you can derive that 1 is tan square theta minus sec square theta is equal to 1. Am I right or not? So here, instead of tan square theta minus sec square theta, I am writing 1 minus tan theta plus sec theta. Okay, and in the denominator, what we have got? We have got tan theta minus sec theta plus 1. Okay, upon tan theta minus sec theta. Okay, in the numerator, if you will see that if you will take 1 as minus as common, okay, sign minus, it will take in the numerator common. So what you will get? You will get tan theta minus sec theta minus 1. Wait, something wrong is there. Anywhere I have written something wrong. Plus 1 in the numerator is plus 1 only, no? It should get cancelled. Oh, it is minus. No, it is plus 1 only, no? Plus 1 plus 1. So it should get cancelled. If I'm taking minus is common, so it will be tan theta plus minus sec theta minus 1 it will be there. Okay. Sorry, tan square theta minus x square theta. No, so tan square theta minus, this will be minus 1. Okay. See, tan square theta minus x square theta will give you minus 1. If you want just positive ones, it will be sec square theta minus tan square theta. Yes. And here it is tan square theta minus x square theta, that will be minus 1. Okay. So it will become plus 1. Okay. So in the denominator, we'll see sec square theta upon plus 1 upon tan theta upon sec theta. Okay. So now this whole will be cancelled. Okay. So you will get as minus 1 upon tan theta plus sec theta. Now, if you want to take minus, remove this minus, what you are going to take, you can take from denominator also minus sign common. So if you take from denominator, so it will be sec theta minus tan theta. And this is your question, sec theta minus tan theta. Yes. Sec theta 1 by sec theta minus tan theta. Anybody, any doubt?
No, ma'am.
Yeah. Be very careful here. Like I did it that instead of minus 1, I wrote 1. Okay. So that's why I was not able to cancel this term. Okay. So be careful. Safia, now you understood?
Yeah. Yes, ma'am. Thank you.
Okay. Good. Okay. Now let's see some more question here. Okay. Now example number 6, if you see, if a cos theta minus b sin theta is equal to x, and a sin theta plus b cos theta is equal to y, prove that a square plus b square is equal to x square plus y square. Okay. So let me copy first. Okay. Now, okay. If a cos theta minus b, so you have got two equations here. You can write that a cos theta minus b sin theta is equal to x. You can write it as 1. And a sin theta plus b cos theta is equal to y is equal to 2. Okay, now you have to prove that a square plus b square is equal to x square plus y square. Now, if we are going to add both the, by squaring, if you are going to add both the equation, see, so on the LHS side, you can get x square plus y square. Okay, first let me square it. Okay, and then I will add it. Okay, I'm squaring both the sides. So if you will square, I'm just flipping or not flipping, then also you see, I'm squaring both the equations. First, I'm writing squaring both equation and add it. Okay, if we are doing the squaring equation, so it will be a cos theta minus b sin theta. Okay, what I will do, I will expand and write, and only you will minus subtract it. Okay, okay. So it will be a square cos square theta plus b square sin square theta, and since the sign is minus in between, so it will be minus 2ab cos theta sin theta, okay, is equal to x square. Okay, and now if the second term, if you are squaring and adding, so it will be a square. I'm writing the sign terms at sign place and cos. Okay, let me write here sin square.
Ma'am, can you do this sum just one thing? Can you just explain it just once?
You want to explain it?
Yes, ma'am. No, you explain it.
Okay, from the starting.
Yes, ma'am.
Okay, see here from the question. Have you read the question? So here are two equations given to you. Okay, that a cos theta minus b sin theta is equal to x. This is first equation, and the second is a sin theta plus b cos theta is equal to y. And now you have to prove that a square plus b square is equal to x square plus y square. Okay, so you have to use both these identities, and you have to prove that a square plus b square is equal to x square plus y square. Now, in this proving, you can see there is no sign, there is no cos. Am I right? But if you see the RHS here, it is x square plus y square. And in the given equation, you can see in the RHS only will be x and y. If you are going to square the first equation, you will get x square. Okay. And this side, I'm not talking LHS. And in the second equation, if you are going to square, so you will get y square also. Now, x square plus y square, how you can get? If you add the both the equations. So that only I'm trying to do. I'm squaring both the equation and I'm adding. And let's see what I will get. Okay. For proving. So if I have squared the first equation. Okay, if you square the first equation here, am I having some place here? Okay, if you square the first equation, a cos theta minus b sin theta whole square, it will do whole square, so it will be of the form a minus b whole square. So what it will give you? A square plus b square minus 2ab. That only I've written, a square. So a cos theta is your a. So a square cos square theta plus b square sin square theta minus 2ab. So 2, the first term is a cos theta, second term is b sin theta, b sin theta. Okay, you can see here. Okay, and then second one also I have done the same thing, squaring. So a square sin square theta plus b square cos square theta. Now it will be plus 2ab cos theta sin theta. Okay, is equal to y square. Now as we are going to add, so in the LHS you will get x square plus y square. Now if you see, both the term can get cancelled here. Okay, I'm using another pen, so no confusion. Okay. So both the terms will get cancelled here, and here what you will get, at the first one you can see you can take a square as common. So you will get sine square theta plus cos square theta. And in the second one, you can take b square as common. You will get sine square theta plus cos square theta. Okay. And here you have already got that x square plus y square. Okay. So now sine square theta plus cos square theta is equal to what? Anybody can tell me? From the identity, we have read identity of
One.
sine square theta. Yes, it is 1. So it will be a square. It will multiply by 1. It will be equal to. So is it true or not? This will be equal to 1. This will be equal to 1. Okay. Any doubt in this question? Anybody? So that I can if anybody wants, I can explain it again, or I can, whatever steps I have skipped, I can just write down those steps also. Safiya, do you have any doubt? Rushil, Rudronial?
No, ma'am.
And one last explanation for this question, ma'am.
Okay. So why I did the square and added? Understood, Shazan?
Yes, ma'am.
Okay. Now, if you are going to square the first one, so what it will be? A cos theta minus b sine theta, okay, whole square is equal to x square. This will be equation, and this will be a sine theta plus b cos theta whole square is equal to y square. Now, this only I have expanded. X square, y square you have already got, okay? But a cos theta minus b sine theta whole square I have expanded directly and I have written here, okay? So a cos theta minus b cos theta whole square will give you what? A square cos square theta. The first term square, a square plus b square. So a square is a square cos square theta, because first term is, this is your a, and this is your b.
Ma'am, I understood the question. I understood.
Okay, so a square cos square theta plus b square sine square theta minus 2ab cos theta sine theta. Okay, and I have not written, like I have written the a term at one side, as you can write 2a cos theta b sine theta also. Okay, the second term will expand to a square sine square theta plus b square cos square theta plus 2ab cos theta sine theta, because here in the between it was plus sign. Okay, and the LHS both the RHS x square y square. Now after squaring they added, so what I got? Minus 2ab cos theta sine theta is in both. One is minus, one is plus. So it got cancelled. Okay. Now if you see the first term, a square is common. Okay. So I have taken as common. In fact, if you can take cos square theta also common. Okay. When you're adding, if you take cos square theta common, so you'll get a square plus b square. But here what we have to derive, we have to cancel cos theta sine theta. Okay, everybody, whenever you are proving or whenever you are solving this type of question, you have to check what you have to prove. Okay. Now here I wanted a expression free from sine theta, cos theta. So that's why I have squared also, because cos square theta plus sine square theta will give me 1. Okay. So I have taken a as common in both the expression. I got sine square theta plus cos square theta. In the second, I have taken b square as common, sine square theta plus cos square theta. Okay. Whenever you are doing proving in trigonometry or anywhere, you have to check with the question and what should be your RHS. Accordingly, you have to work. Okay. So now, sine square theta plus cos square theta, as we know, it is 1 from the identity. You have to write on the right hand side, okay, of your copy, that using, since sine square theta plus cos square theta is equal to 1, therefore ये आप expression करोगे, ठीक है? So a square plus b square is equal to x square plus y square, because this is equal to 1. A multiplied by 1, b multiplied by 1. So it will give you a square plus b square is equal to x square plus y square. Now any doubt? Any further doubts? Everybody has done the assignment A3. I think 2 assignments were allotted to you, A3.1, A3.2. Everybody has completed that assignment.
A3.1 I have completed.
Yeah, very good. Try to do A3.2 also. A3.1, in fact, I have covered all the questions of A3.1 in the class only. And A3.2 are the questions that are based on your A3.1. Okay. Now the last question here. So if tan theta plus sine theta is equal to m. Now here again, two expressions are given. Okay. 2 equations, in fact, you can say are given. Tan theta plus sine theta is equal to m, and tan theta minus sine theta is equal to n. Now you have to show that m square minus n square whole square is equal to 16m square, or you can just more simplify and write as 4 root mn. And here m square minus n square. So now what do you think? How we can prove the copy?
Using the identity.
Of course, we are going to use the identity, but what will be the steps? Because identity cannot be used just statically. Okay, when we will simplify more and more, then we can see that which identity you use. Okay, so what do you think? What should be our first step? See, your 2 expressions are what? Yeah, tan theta plus sine theta is equal to m.
And tan theta minus. Ma'am, there are 2 equations. So ma'am, there are 2 equations. Now we square both the sides.
It is not compulsory that you are going to add both the sides. According to the question that time I have done. Okay. Here, if you can see that m square and n square is there. in your expression. Yeah, so in that way, if you're going to square both the sides, what you will get? Tan square theta plus sin square theta. I don't think so. If you are going to square, so what you will get? Tan square theta plus sin square theta is equal to m square. Okay, one no. Wait. Oh, I've written. This question is a little different. Okay, but I'm going with this also. Tan square theta plus cos square theta plus 2 tan theta and sin theta is equal to m square. Okay, and the second you will get as tan square theta plus sin square theta minus 2 tan theta sin theta is equal to m square. Okay. Now, if you are going to now here, if you see in the expression, it is subtraction. M square minus n square is there. Yes. So if you are going to subtract it, so what you will get? You need to subtract equation. Which equation from which equation you have to subtract? M square minus n square. The second one will be subtracted. So it will not be resolved in that way. M square minus n square will give you what? If you are going to subtract, you will be cancelling this subtracting. Wait, I will do this. Okay, if you are going to subtract, this will be plus, so this will be minus. So this will be cancelled, this will be cancelled. It will be 2 to the 4 times sin theta equal to n square minus n square. Okay, now mn. It is you have to derive that m square minus n is equal to 4 root mn. Okay, so we have got this 4, but we have to find mn. Okay, mn. So from here you can write that tan theta. You have got tan theta upon into sin theta. So tan theta can be written as m minus sin theta, and sin theta if you write from here, so it can be written as which you have to write here. Instead of this, you have to write root mn. Okay. So, anybody, any idea how you are going to bring here a root mn instead of tan theta cos theta, tan theta into sin theta? Sin theta can be written as tan theta can be written as sin theta upon cos theta. Yes. So it will be sin square theta upon cos theta. If you write
Okay, show the addition. Can show the addition, please?
yeah. So
Yeah, show the final product of addition.
yeah, this is your final, but you have to get this. Okay. I have done it with different method, but you said so. I was doing in this method. Else, I have done adding and subtracting both, and then I got the value. Okay, but I wanted we have almost got this. See, you have to derive this equation. Okay, so we have already got m square minus n square Shazam. Okay, we have got 4 also, but we have got tan theta into sin theta. Instead of that, we should get root mn. Okay, so if you will see from here, root mn will be equal to what? Mn. Wait, I'm doing in different way. So mn is tan theta plus sin theta, tan theta minus sin theta. Okay, root sin theta, tan theta minus sin theta. Okay, so it will be a plus b, a minus b. Okay, so it will be tan square theta minus sin square theta. It will be equal to tan square theta minus sin square theta will give you what? No, I cannot give you 1 to sin square theta. So you can write in terms of tan. If we are going to write, so what expression we will be getting? Tan of sin square Okay, what I'll do, I'll show you this method that how I can do the method that I'm telling you right now. You just everybody do with that method, okay? And I will check that this can also be changed into what we derive, okay? After this, okay? So this I'm crossing, okay? Just follow this one, okay? If you see both the expressions here, okay? The first one is here. This can also be get converted, but this will go a little further, okay? So for now, okay? So if you see from here, okay, first and second. So what you will get, the two equations. If you are going to just subtract, just add the equations, both the equations, then what you will get? After adding the equations, this sign, I'm writing here, adding equation first and second. Okay, if you are going to add the equation first and second, then what you will get? Your sign, see, your sign and sign will be cancelled because one is in positive and one is in negative. Okay, your sign and sign will get cancelled. 2 tan theta is equal to m plus n. Okay, so you will get 2 tan theta is equal to m plus n. So tan theta can be written as m plus n by 2. Okay. Now similarly, if you are going to subtract both the equation, so one tan theta minus tan theta will be cancelled, and it will get 2 sin theta. You get 2 sin theta is equal to m minus n. You will get subtracting now. So m minus n. Okay, you'll get m minus n. And what will be your sin theta is equal to m minus n by 2. Okay. Now, now from tan theta, you can get what? Cot theta. Okay. Cot theta is equal to 2 upon m plus n, because it is the inverse. And from here, from sin theta, you will get cosec theta. Cosec theta is equal to 2 upon m minus n. Okay. Now, we know the identity of this 1 plus cot square theta is equal to cosec square theta. Okay. Now, we'll put the value in this. Okay. So, 1 plus cot square theta is what? 2 plus 2 by m plus n whole square. Okay. Minus 2 by m equal to m minus n whole square. Okay. Or either you can take 1 on one side and then you can solve. Okay. So it will be 2 upon m minus n whole square minus 2 plus n whole square is equal to 1. So if you are going to square, so you'll get 4 1 upon m minus n whole square minus 1 upon m plus n whole square is equal to 1. Now, if you will do, so you will get, taking LCM, if you do, so it will be m minus n whole square, m plus n whole square, and in the above, we will get m plus n whole square minus m minus n whole square is equal to 1. So, in the numerator, if everybody will check, then it is of the form a square minus b square. So, it will be a plus b, a minus b. Okay. So, if you write a plus b, a minus b, so it will be, okay, so here you can see nn will be cancelled and here mm will be cancelled. So it will be 2m plus 2n. Okay, am I right? It will be 4 multiplied by 2m multiplied by 2n. Okay, so it will be 4mn. Okay, so what you will get? 16mn upon m minus n and plus. Okay, so if you multiply both the terms in the numerator, so what you will get? M square.
M square minus n square whole square.
M square minus n square. M square minus n square. And this will be cancelled. Is equal to 1. So you will get here 16 mn upon m square minus n square is equal to 1. Now you can bring this m square on this side. M square minus n square. And from here you have already got the expression. Okay. This is whole square. Sorry. Okay, m square minus n square is equal to 4 root mn. Okay, any doubt?
No.
Okay, I did this with a different one. Okay, see, from both the equation, when I added the equation, then I got cot theta is equal to 2 by m plus n. And when I subtracted the theta, actually I got the expression in tan and sine. Okay, but why I changed cot and cosec? Because in tan and sine, I was not having a single identity. Okay, in cot and cosec, I got a single identity where I put the value. That is 1 plus cot square theta is equal to cosec square theta. And I have just put the values of cot and cosec that I have got from these two equations. Okay. And then after that, I have just simplified. You can see there's nothing much. I have just simplified all the expressions. And then I have got in the end the derived value. Okay. And in this way that we have done here, it is little, what you say? We have got the expression, half the expression, but this tan theta into sine theta should be root mn. Okay. Everybody try if you can change it to root mn, okay? But it cannot be done directly. Either you take the value of tan theta from here, okay? Any doubt here in this expression that I have done?
No, ma'am, no doubt.
So shall we end the class here only because it's already 50? Okay.
Bye, ma'am.
And next class, before next class, just go through all your assignments. If you have any doubt in any of the assignment, any of the question, just clear your doubts. Else we will start with a new chapter, that is application of trigonometry. In application of trigonometry, the main application of trigonometry that you are going to study, that is height and distance. Okay, how to measure the height of a building, the angles at which the angle will be taking the height, all this. Okay, there's not much, only problems will be there. Okay, so remember all the theta value, sin theta, cos theta. Okay, so all the values, just remember what will be the value of 30 degrees, 60 degrees, 90 degrees, 0 degree. Okay, because there you will need it. Okay, everybody. So I'm ending the class. Till then, bye bye.